Can you really measure the light? Well, there are many ways to measure the required lighting for your home. Today, I'm going to explain how to choose an effective lighting solutions for your home or office. Welcome to Live for Yourself. In my previous video, you have seen how the lights are being made at the factory and who are the key people who have done contributions to develop the concepts. So, can we really measure the light? In this video, I'm going to explain how to choose an effective lighting solutions for your home or office. Before we go ahead and understand about it, we need to know how to identify the required amount of lighting for your home. Today, we have many lighting manufacturers who offer a wide range of products that fits for your home and office. As the inventions and discoveries about the light sources were going on and it was proved that lighting is an inevitable part of human being, the humans were more concerned about the energy required to illuminate the area. Why? Because the cost of energy consumption was way more than anyone could even imagine. Only the richer could afford buying an electric bulb. Strange, isn't it? Energy savings has become a priority and the energy consumption needs started becoming inevitable. So, a set of engineers decided to create some standard values for the required lighting to save the energy consumption. Lux meter. This is the device used to measure the light. The display will indicate how much lumens light are on the specified area. An advanced method, called the dialux, is used nowadays to understand the estimated lumens light that will be required to illuminate the area even before you construct your house or office. This created a massive demand for energy-efficient lighting. Have you ever wondered, the light you see is just a bunch of technologies combined together into a compact object? Based on the requirement, the two factors decide what type of lighting to be used. 1. Area of lighting. 2. Type of lighting. If it is installed in an indoor space or outdoor space. If you need it for your home or your garden/walkway. There are many factors to be evaluated before selecting the lighting. Have you ever imagined, if there is no sun, what would it be like living in the earth? The sun is the benchmark of the lighting spectrum. Each color is differentiated as its own. The sun's light is given a standard value of 1 or 100. A color rendering index is a quantitative measure of the ability of a light source to reveal the colors of various objects faithfully in comparison with an ideal or natural light source, the sun. This is one of the reasons why the apples are seen in red and orange. Unified Glare Rating, UGR. UGR is an objective measure of glare that is used by lighting designers to help control the risk that occupants of a building will experience glare from the artificial lighting. UGR values range from 40, extremely high glare, to 5, very low glare. Color temperature is a way to describe the light appearance provided by a light bulb. It is measured in degrees of Kelvin, K, on a scale from 1000 to 10,000. For normal lighting purpose, light sources starting from 2500 Kelvin to 6500 Kelvin is used nowadays. You can choose the color temperature as per your interest. Did you know that your actual power is not being utilized in your lights? Here's why. Every electrical equipment, based on their assembly of components, will have some loss of power when connected to the electricity. The ratio of the absolute value of the active power to the apparent power is called power factor. A low PF increases the current load and the energy consumption. So, how long these lights have to be on? Based on the switching cycle, on and off, and the amount of time the lights are switched on, the light sources can burn out. In the lighting industry, a bulb's life is rated as ARL or average rated life. The LED lights have a greater lifespan than a traditional incandescent lamp. In the early 20th century, many scientists have started conducting experiments with various chemical elements and crystals. As a result, the light-emitting diode, LED, are invented. A light-emitting diode, LED, is a semiconductor light source that emits light when current flows through it. LEDs have many advantages over incandescent light sources, including lower energy consumption, longer lifetime, improved physical robustness, smaller size, and faster switching. Have you ever wondered why the LED light switches on so fast? Here's the reason. The LEDs use DC current to switch on. When powered, the instant current flows through the circuit, and, the result, your lights are on, in no time. This is one of the reasons for replacing traditional fluorescent lamps to LEDs. In the traditional incandescent lamps, the magnetic ballast drives a lot of energy to switch on. The LED technology have overcome these issues since the LEDs use DC current to switch on. The electronic ballast or drivers used for the switching and converting AC to DC current reduced the energy consumption to almost 50%. So, ideally, the amount of energy consumed in a year is reduced to 50%. That's interesting, isn't it? Now, you understand why choosing the lights are so important as choosing a car with good fuel consumption. LEDs are not only a money-saving technology, but also a clean energy resource. LumaLEDs, a lighting company, was formed in November 1999 as a joint venture between Philips Lighting and Agilent Technologies. This company develops, manufactures, and distributes LEDs, light bulbs, and related products for automotive lighting, general lighting, and specialty lighting. LumaLEDs became a business unit within Philips Lighting and became known as Philips LumaLEDs Lighting Company. LEDs have many advantages over incandescent light sources, including lower energy consumption, longer lifetime, improved physical robustness, smaller size, and faster switching. Have you ever wondered why the LED light switches on so fast? Here's the reason. The color of the light, corresponding to the energy of the photons, is determined by the energy required for electrons to cross the band gap of the semiconductor. White light is obtained by using multiple semiconductors or a layer of light-emitting phosphor on the semiconductor device. The LEDs require 30 to 60 milliwatts for the switch on. When these DC current is passed through the LED chip, the phosphorus crystals emits light and pass through the lens. The result is a constant white light. The LED chip is encapsulated inside a small, plastic, white mold. It can be encapsulated using resin, polyurethane-based, silicone, or epoxy-containing, powdered, cerium-doped YAG phosphor. After allowing the solvents to evaporate, the LEDs are often tested, and placed on tapes for SMT placement equipment for use in LED light bulb production. These LEDs are assembled into a printed circuit board, provide 18 to 22 lumens per watt. This process also produces heat up to 150 degrees Celsius. There is a heat sink placed behind the printed circuit board to cool down the circuit assembly and thus maintaining an ambient temperature environment. Based on the phosphor content, the LED color can be changed. There are various types of LEDs are available in the market. The basic types are medium and high power LEDs. The medium power provides 65 lumen per watt at 20 mA, where the high power provides 165 lumen per watt at 350 mA. Quantum dot anodes are another type of LED technology that is used in TV screens, computers, smartphones, etc. Different manufacturers: Bridgelux, Seoul Semiconductor, Samsung, Cree, Nichia started taking patents for their LEDs, and now the LEDs are available in different prices depending on your need. But, while selecting the lighting, there are 4 things you need to make sure. 1. Quality. 2. Energy Star rating. And, finally, the price as per your budget. Okay. Now, you are going to a shop who sells 10 watts LED bulb of X manufacturer for $5 and another of $10. As an initial cost saving, you tend to choose $5 LED bulb, and it may result you in changing these bulb 3 times a year, due to the low quality components. So, instead of saving the 50% energy, you will be losing 3 times the cost of saving. The electronic ballast, or the driver, is one of the key component that decides the lifetime of a LED light. The basic principle of LED driver is to convert the AC current to DC current. Simple. Now, think about that $5 LED, the LED driver used in this LED light might be only partially converting the AC current to DC? What will be the result? The LED starts to blink. So, if you turn on your LED for 8 hours, it flickers all the time. Human eye can see the flashing of the lights up to about 50 to 60 flashes per second, 50 Hz to 60 Hz. Most sensitive frequency area for human eye is the range from 10 Hz to 25 Hz. When the frequency is higher than 60 Hz, most people can't detect the flicker anymore. Some people have been known to see the flicker up to 100 Hz. When you choose an LED, you need to make sure it is cost-saving and anti-flickering. Always prioritize quality over the price. Choose wisely, and live happily. Your home is your priority.